Okay. So first of all, I'll just quickly introduce myself. So I'm Athan Nesbitt, and I'm leading the high available sort of functional team here at R3. So this design proposal is really about our work towards the cost effectiveness of Corda, towards scaling it up. But I do want to be clear that this is actually quite a detailed and restrictive portion of that work. So I know there's probably some hope for a broader discussion on multiple identity and large clouds of nodes. Now, there will be more design reviews coming up on topics to do with that, but I'm trying to keep a phase of that I'd like to deliver soon. So here, when I'm referring to a multiple identity endpoints, I'm really of a secure communication layer and hosting a Corda firewall that can basically expose Corda nodes where there are several nodes, whereas at the minute, the current node is only able to expose a single node. So as I say, it's quite a deep sort of technical thing. I'm sure that there will be some time at the end for a discussion on maybe slightly broader topics. I'm trying to keep this really to a restrictive design review because it actually raises already some interesting sort of technical challenges. First of all, why are we aiming at doing support for shared identities between a limited number of exposed physical addresses? Is really because when people are coming to us to do their offering, they are wanting to run lots of nodes in many cases. They're often wanting to do this with clients, and because they're wanting to scale up, and because they're wanting to deal with different accounts which have isolation rules with regard to the data. Now, the current offering, as I say, allows one to host and port with a node and possibly to have some load balancing or failover protection on that. But obviously, if you start scaling up to tens, hundreds, thousands of nodes, then that becomes quite a challenge in terms of resources that you need to support that. You have to run a whole bunch of processes. You need to run a whole load of firewall rules. Obviously, it's not very agile if you need to add new nodes, new customers. So it's obviously highly desirable for us to have some mechanism to provide sharing. Now, at the same time, investigating into this, so we've been doing some POC work to see what approaches to do this. It has highlighted to us some compatibility, mostly forward compatibility issues that we are going to basically need to look at and try to decide. Because we basically guarantee with the Corda protocols that we are compatible, and this does, start to ask questions about what is compatible, when we allow, what are the requirements on those, how can we minimise impact of change for this facility. So here we're really trying to propose a choice of options that's ranging from a fairly fast to market approach through to some broader ranging approaches that we might pick, and partly to highlight the compatibility questions, partly because this is setting changes in protocols that will be present in the network for a long time to come. So there are some sort of specific things that it decides. So we're wanting to really ensure that everyone is agreed with the decision made, because we are going to be living with this for quite some time. And as I say, also just just partly to hear the appetite for some of these sorts of changes. So that is really the purpose of this DRB. As I say, there'll probably be other DRBs shortly that we'll be talking about more back-end changes to host multiple identities. But this is really talking about the front door, where you expose your set of nodes to other peers, to the internet. Drilling a bit
Okay, I have a very quick question. The last bullet on the previous slide. The DRB does not address support for multiple signing identities on a single node.
No. So it is assumed at this point that a node is hosting its current Corda certificate hierarchy, which essentially ties you to an X500 name and signing keys. Also, that doesn't restrict the use of anonymous keys, but it is stating that a node at this point would be a distinct process. Now, so the next stage of evolution is to try and support sharing of physical resources to run multiple identities. We'll have discussions about that later.
Okay, fine.
So this is quite a detailed thing, so I'm going to try and explain a bit about how Corda flows actually communicate with each other and how we have quite a lot of constraints in terms of assuring reliable communication between nodes and secure communication between nodes, because this is what we have to modify slightly to support the ability to communicate. So when we have nodes communicating for flows, peer-to-peer, all the communication is encrypted using TLS 1.2, and for our packet control and messaging format and the protocol of things like flow control, we're using AMQP. So all the communication here is assumed to be AMQP 1.0 over TLS 1.2. The routing architecture of Corda is that a flow wishes to communicate with another node. It will look up the information for that as part of the flow, part of the business logic, in what we refer to as the network map cache service, which is hosting the directory of connectivity information, key information for the destination node, the peer. We will then obviously have that the flow wants to send a message to them. So the lookup process will identify the target host and port, to identify the target key address, and there are implicit things here that the target will present a TLS certificate that is bound to the same X500 name as the signing identity X500 name. So the certificates there are actually paired, they're a part of the issuance process, but they are constrained by name constraints, so they can't be changed. We have reliability guarantees. So in fact, the node doesn't just immediately try to send a message to the peer. The node actually reliably commits the data into the local Artemis in a per target queue. It requires an acknowledgement assurance of that, and the checkpointing logic of the node will ensure that if that weren't to happen for some reason, I get interrupted at that point, then it will resubmit that. So our delivery guarantees are for at least once delivery ultimately to the target. They are, with DGUPs, managed by the nodes as part of the checkpointing. So as I say, each target will have a queue that it goes into at the minute, and then there's a bridging process that will now try to deliver those messages from the local kind of pending queues to the target inboxes. Now, that process is run through, in the sort of full enterprise solution, through our Corda firewall, and the sub-portion of the Corda firewall for the outgoing path we refer to as the bridge. And that will essentially try to initiate the connections to the target. That will check the certificates exchanged during the SSL handshake, TLS handshake, to ensure that they are correctly routed, to ensure that they're a valid chain, to ensure that the X500 name contained in the essentially the target certificate is as expected. In return, the server on the far end, the target, will also be requiring client authentication. So we will be presenting our certificate to them. So that ensures that we're verifying that we are a member of the compatibility zone, that we have got a correctly routed certificate. However, obviously, as an incoming connection, an unsolicited connection, there's not much further checking can be done of the X500 name other than later that there is, a correct membership that it is actually for a node that we're hosting there, so that it's in the network map, because it's an incoming direction. Now that would typically, in an enterprise solution, terminate on a float process that is in the DMZ, and that's really a forwarding tunnel. That's really just forwarding the secure delivery acknowledgements through ultimately into the target's own Maximus broker. So we're trying to get it into the durable inbox of the target, and that delivery will eventually hopefully succeed and acknowledge, and that allows us to finally remove the resource from the source pending queue. So the bridges and floats here are all essentially stateless apart from some in-transit messages. So they're holding on to a relatively finite sliding window of messages in progress, which helps us with recovery in HA scenarios. But all of this is tightly tied to the presentation of certificates. Now this means that in a scenario where we are actually starting to want to host multiple nodes on that endpoint, we now have difficulties that this expectation that we're going to get the correct certificate presented to us starts to become more challenging, because obviously there's a choice of endpoint targets. It also potentially might require that we start to modify the node info structures, the information that we distribute in the network map, so that we can actually explain these more complicated relationships between the physical target address and the X500 names. Now this is a thing that we can perhaps not do. But it may be desirable to do it, which is one of the decisions that will be associated with some of the choices here, is whether or not we should do that. Now, the HA team has actually done some POC work of one of these suggested solutions, because it's the solution that we were most able to make progress on. We did look at all of them, but the one that we most fully developed here is our proposed candidate, which is to start to use server name indication, which is a standard TLS facility, and in fact it's actually going to be mandated in TLS 1.3, so it's actually probably compatible with that as a requirement, to indicate which node we are connecting to or wish to connect to as a source. There are some challenges with this though, so we'll get to the pros and cons of that. That will discuss some of the challenges we met. Now we believe, solutions for that for the server name indication, but we might be able to do the same things through some other routes involving node info. So we will discuss sort of the trade-offs there, and mostly with regard to delivery times and risk profiles, but we'll get to that. The other further out alternative perhaps is maybe this is indicating that these compromises are challenging. Maybe we should consider some other approach. There may be other approaches. Some ways that we could consider that we extend some other endpoints or something, but there's a discussion to be had, I'll say a bit further on. Basically then is to go with using surname indication to disambiguate the target we're aiming at. Now, this will be a process that's reversed in the other direction, where essentially we always dial back to ourselves so when the target is replying back with responses, they are going to independently initiate their connection to us, and they may potentially need to surname indicate which of our sources is the one that they're talking to. So if we have two clouds talking to each other. Now, the suggestion here is that using surname indication, we'd be able to select the correct certificate to present from the target. There are complications in this, which I'll get through in a moment, but the key part here is that it would allow us to start to share the Maximus broker resources, so that we can have shared out queues, so we can basically share the Maximus broker between several enterprise nodes. It allows us to share the bridge, so that also reduces that. It allows us to share the float, so it starts to reduce DMZ machines that we have to expose, and it clearly allows us to start to control our firewall rules, so that we're allowing incoming connections to the float on a very restrictive inbound address. And similarly on the outbound, we're now dealing with only one initiator for the outbound connections to the bridge. So it does have clear benefits in terms of the sharing. It certainly seems like a workable solution on the outset, and so this was, was a fairly quick design for us on our initial evaluations to attempt. And it does have the advantage that the SNI is something which is very standard in TLS, and we would be able to fairly easily add it to nodes that perhaps don't support the whole range of functionality here. They might not support the multiple node enterprise bridge structure, but say open source nodes could very straightforwardly add a header and maybe add that well in advance of us having such enterprise nodes in the live. So when we went through the design process, we discovered a set of constraints which we have solved. So essentially, going through the cons first, just to sort of go through the sorts of things we have to solve. One of the cons is that pretty much in common with all of these approaches, if you are an old current implementation of Corda, you will not know to add this header. Your software would have to be upgraded to add it. And because of the dial back behavior that we have, you would maybe be able to send a message, but you probably wouldn't accept the certificate on the far end, and that would immediately terminate the connection. And in fact, we have got some facilities in Corda that essentially blacklist incorrect certificate endpoints. So it would actually mean the communications would cease there, and the flow would be paused. The flow would be recoverable, but the flow would be paused. So that is a challenge with regard to forward compatibility. Backwards compatibility, obviously, if a node that doesn't apply the SNI header connects to a single endpoint target, it can happily give as a default response the one certificate it's got, and so there's no difficulty there for the existing single nodes. And that might allow a sort of softer introduction phase. We did discover that the SNI header standard, whilst it outwardly appears to be quite flexible and allow multiple addresses and allow multiple address types, unfortunately, earlier implementations of PKI spec seem to have made mistakes that have led them to restrict this. So in fact, only allows DNS names. And this is a bit tricky because, unfortunately, our primary addressing is not DNS name based or IP address based. It is, in fact, the X500 names. And the character set that is using DNS therefore doesn't allow spaces or commas or equal signs, which are all portions of a standard X500 name. So we can work around this. We can use a non-standard hash of so we canonicalize the X500 name and we hash it and we append it to essentially a kind of pseudo DNS postfix. So, it could be the hash dot corda.net or something as a sort of pseudo name, and we can, we have demonstrated this will work. It does actually provide perhaps a little bit of privacy even, so there might be some privacy in that, but I have to say it is non-standard, and if we do pick on a particular pseudo DNS name, we're probably stuck with that forever. So this is something that we would have to consider, what is an appropriate neutral name for it? Would we want to have Corda in the name, or is that regarded as something might change? So there are actually some decisions to make there about the structure of that, because we would be setting it in stone for a long time to come. Whilst I say TLS 1.3 will mandate server name indication, we're not quite sure, because there aren't many concrete implementations out there. Are there any difficulties with using essentially the base 58s of hashes or anything? We have yet to see those, but I think we'll probably be compatible with that if we're compatible with the current implementation standard. We did, because the return path uses the presented client certificate to confirm the source, and then use that as part of replies, we do actually still have to create TLS connections per conversation. So if we have a cloud of nodes on one site, one business network operator talking to some nodes on another business network operator's location, we are actually going to make up a number of TLS per conversation. So that will require us to probably spend some more work on resource management, so we can tear those down. The minute we generally don't tear those down once they're initiated, they're lazy start, but they are kept going for a long time. There were some minor technical challenges with just the bridge control logic. We also, to allow us to be more agnostic to the number of nodes running, sharing the Artemis broker locally, we had to do some extra filtering and message affinity inside the local queues to allow us to consume the right messages to each TLS outgoing. That was a bit complicated, and we are depending on some features of Artemis that are a little bit Artemis specific, so message filtering is a little bit tied to the flexibility of Artemis message filtering. But I don't think, I mean, these are features that are quite common in other middlewares, so it doesn't particularly tie us on that. So we were able to work around that. So those are the cons, but the advantages are definitely in terms of relatively easy to add. We have a working POC, we were able to get full functionality. So the scope of the changes was quite localized. It was in a fairly small portion of our code base. Our actual kind of N2P protocol handler section of the code is quite well localized. That allowed us to make this change pretty quickly. And so these are all, you know, suggesting that the full productionized version of this is achievable. So I have a high confidence in this particular approach. But, you know, there are quite a few slightly ugly things there. There are some constraints there that maybe we would like to think about. So that's the first approach, really. The second approach is to start working in terms of extensions to our network map information. Now, we would still require that we're presenting appropriate certificates and things, but here what we're saying is that perhaps if we weaken the relationship between X500 name on the TLS endpoint and the signing identity that we are using, that might open up the facility to connect to a kind of shared certificate. So when we go to the other nodes, the other cloud nodes, we were basically expecting the network operator certificate, shared group certificate. We would not then have to depend on some features, sort of slightly adjusting the SNI, but there are, when we started to go down this route, we're trying to some broader technical things. So one of the challenges is that the link that we have at the minute, the name constraint link and the constraint we have, does mean that we're able to reliably ensure that the issuance of the identity certs is controlled. It's controlled by the doorman of the network. Whereas if we break that link, then perhaps maybe you could hijack someone's TLS connection and sort of associate it falsely with an identity. So we might have to consider, are there security implementations? Is there risks to the protocol if we allow that? So that's one potential thing. It might be surmountable. It might just take some more design, but it did raise the questions. We still actually have the same kind of resource sharing limitations because we still have to ultimately present the correct return certificates. We still have to say that we're coming from a source. So it hasn't actually restricted the sort of resource aspect where we're making a TLS connection for the conversation pair. We are also, you know, it does mean there's this bit of asymmetry in the certificate. So we're going to a group certificate that we're then sending from a specific certificate. That might make it quite easy for the code to get confused. It might be possible to confuse things. And then really the larger issue is that node info is actually got a large part of our infrastructure in that our code base uses it in all sorts of locations. It's used in flows, service hubs. It's used as part of our tooling for the Dorman and the network MAC are using it as a signable resource. Now, all of our Corda serialization is extensible, but it would be very easy for something to slice a key piece of information off, and then maybe that would make it that the conversation only work one way. It's quite hard to reason about, and we would have to change a lot of places quite carefully. So that my team's feeling on this is that there is a higher risk with this approach, delivery times, and I think a shared bridge with the appetite for it we're hearing is quite strong. So that's why we're not recommending this as strongly. It may still be necessary to extend that info for other purposes, but I think in the near term, it's not so deliverable. It has extra complications. Certainly, we might be able to revisit this if there are other changes to certificate structure because of other demands, other aspects of security policies and PKI, but at this time, this is definitely not my team's suggestion, but it is an option we wanted to highlight. So moving to the sort of next option. Now, this is a much more radical suggestion and perhaps not suitable anytime soon, but there is the question that these constraints we're hitting where we are using the relationship between TLS identity and the source signing identity might possibly be broken by extending the actual application layer packet protocol, by adding extra headers, by basically source tagging to ensure that the routing can be done there. Now, that sort of source tagging does have to be done carefully. There are all sorts of classic ways in which you can trick people into signing things they shouldn't. So there would have to be a well-designed protocol for that. It would have to be done with nonces and things to ensure freshness and possession of the key. Now, that would probably, I would argue, be best done as part of some sort of end-to-end encryption, perhaps. Now, this is being suggested not something that we've really attempted because it is a broad change, but maybe it is a thing where we need to think about longer-term extension. Do we need to start maybe at least laying some groundwork for this?
I think it's probably better if we treat that as a separate project from the current work because, yeah, this proposal is essentially implementing a custom encryption protocol and ignoring TLS practically. At that point, TLS isn't even really adding anything and could be scrapped entirely. That's really fairly subtle.
Yeah, no, I know, and I'm not really. I'm suggesting this because I'm just saying, is it a thing we need to be thinking about what's going on? Not a thing that I think is any near-term deliverable.
Yeah.
But we are, as we constrain ourselves, I think we are making ourselves. Well, we basically we commit to these wire changes. We commit to them forever. So, is this something we should be on site adding some resource on?
Yeah, I think if we were to do this sort of end-to-end encryption and things, this is sort of useful if you want to have nodes that are, not running on servers all the time, and they're being supported by message buffers in the cloud or whatever. It would probably you would probably want to implement it simultaneously with mixed networks, like Tor style routing, because
exactly.
then you would end up you would want a Tor-like protocol, I think, on top of flows or something like that, and you would get this sort of thing.
You have talked about such things in the past. I'm just really asking what is. I agree. I think the appetite for this is probably low because we all want to get business networks out there now, but just really including it complete in the design view, really.
I mean, so the primary benefit here is you're saying, well, fewer TLS connections, basically, between the bridge. But a TLS connection is a fairly cheap thing. It's a sort of in-memory, bunch of counters and nonces and things. So I'm not too worried about the cost of having lots of TLS connections between the same servers. I think to justify a fairly big change to the protocol like this, we would need features, basically, and a mixed network where we could do things like hide the origin of a request to a notary, for example. That would be a feature which is probably could justify the cost, or supporting nodes running on smartphones or little compute appliances behind NAT boxes and firewalls and things. Consumer Corda would justify that, but I don't think it would just be justified right now.
Yeah. So that's really the sort of scope of things we consider design-wise that might solve the particular design challenge we have here. I mean, as I say, our recommendation is we'll go with the SNI approach. I'll have to agree, obviously, on the format of this SNI header because it's a bit non-standard. We are confident we can do this at low risk. I would say that we do need to look at node info evolution and possible other protocols going on. But I'm not saying that's anything near term. I'm just saying my feeling is that the network protocol is quite challenging to extend. So we are things to consider.
The changes that we can put in now, we don't take advantage of them, but
Maybe.
the change that we can do now just to provision for changes down the road, and it's less painful to make change now than it is in the future.
Well, I think, so we've already got that the node info has got version information. The question is, do we need that maybe on a per endpoint basis rather than on just a global? So maybe you could specify here's the version 3 socket and here's the version 4 socket. I don't know. There possibly some changes in the structure might just help with future nodes which connect to the channel that supports, slightly different wire protocol.
Yeah, I think we've already got a fair bit more support than most protocol designers have, because usually you just connect to a port and hope that you can talk to whatever's there, no matter what version it is. Whereas we have this whole directory which tells us ahead of time what we've got, actually, which is pretty nice. I don't know if I think we can easily add fields to node info as long as they're nullable, because that's just data structure evolution. So in this case, from what I can tell, we can just start adding an SNI header. And the older nodes won't break because it's there; they'll just ignore it. Is that?
Yeah,
did I get the right impression?
It might partition the network for them a bit. That's the only risk. Is that if they are refuse to upgrade, then they wouldn't really be able to have a full conversation with a group of nodes. So
just to clarify, I think what you said earlier, an old node can't initiate a conversation to a new node.
Well, no. So that's exactly analogous to the same problem when host headers were added to HTTP and when SNI was added originally to TLS, right? I mean, it's sort of inherent in the nature of what you're doing of overloading IP addresses. Yeah. The alternative is to just not support this and just say, well, every identity gets an IP address. Go request 1,000 from your data center operator. It's not necessarily unfeasible.
Every host gets every identity gets an IP address or port on the same IP address, but that's the correct design in there.
IP address or port. Yeah, so it maybe simplifies things operation if you don't need to do that. You can sort of work around it in the past.
One of the main objectives of this, from my perspective, is the ability to share resources and thus reduce the cost of running large-scale deployments of this sort. So it seems to me, am I right in saying that only the option 3 kind of gives us fully mutualized costs across the infrastructure? What's the difference?
You get 80-90% of what you need for resource sharing from just the SNI, actually. Because it's mostly about running less processes, it's about having less hosts, less firewall resources. So you do get a lot out of this.
Except for the bridge. The bridge has to be per identity.
No, that's not talking about this.
Even for SNI.
The bridge is now over the front of.
Yeah, we will have. Yeah, we will have some time, so we might use some of the remaining time in the DRB to discuss some other parts of the multi-identity on one node plan.
Yeah.
I think you asked questions about that.
Not on my slides. Is really about what's the sort of rate at which we would push this out. Would we want to have the current open source 3.3 release or very near-term release starts to include the SNI header in the standard format? So it's at least advertising who it wants to talk to, and then merge in the support in enterprise to fully support bridges with several nodes behind them, or are we just going to wait till sort of 4 or 5 or a slight breaking sort of release and do it all at that point? That's really just kind of network evolution question, really.
I think 3.3 only has a few more days left before it closes, right? So that really,
I think
that really depends on how ready the code is. We've got a question here on the chat from Mohammed, actually, but I guess we should get to that in just one sec. With respect to scheduling, if the code is working already, I saw a couple of things maybe we could tweak, like maybe instead of hexacoding, we can use base 58. That's a bit shorter. We probably shouldn't put something .corda.net because we've made this mistake before. That's a real domain name.
Yeah, there's a question I'm asking, so yeah.
Yeah. So we should probably put it in a fake DNS hierarchy because it's not really a name.
Does it need to be a pattern match to a DNS hierarchy?
Yes.
It needs to look like a domain name.
Yes.
Yeah.
Does it have to have dots in it?
Does it have to have dots in it?
I think it should have the normal number of levels for DNS.
Sorry, you just hang on a second. This goes both ways. So we shouldn't. It certainly shouldn't be a domain name that we use for something else. But we've also been there where we've used a domain name that didn't exist, and then it existed, and all hell broke loose. So let's at least point to what we do control, but use for nothing else.
In the spec, it is regarded as a hint to the server. It is not.
Yeah.
Just unfortunately, the historic reason they limited it to DNS names only.
So can we have something hex or base 58 dot?
Yeah.
At the moment, I have R3 dot the hex.
Yeah.
Yeah.
Okay, so Hamid on chat asked, the proposed change to just having different TLS certificate and signing certificate, is the understanding correct? That was one of the proposals, yes? Or rather, it was suggested that that's unlocked by these?
It was one of the suggestions. It is, as I say, if we weaken that link, there is questions about, we'd have to analyse the security aspects.
Yeah. So is the complexity level significantly high to introduce standard CA for TLS? If standard CA are included for TLS, communication enterprises can leverage existing process for configuration. I don't think. Go ahead, Matthew.
So standard CA certs for the TLS might be feasible if we can have any, but yes, we'd have to discuss how can we bind the names in a way that we trust. Basically, that's
I don't think we're going to go there because CAs issue certificates for domain names, which they have to check you control. But legal entities don't always have domain names, right? There's one domain name per like brand name, basically, or like logical organization. But Corda is pretty explicitly oriented around this notion of a registered legal entity, because when you trade, that's often more important than the brand name. It also, I don't know if it really simplifies anything operationally, because you still need to have the Corda firewall set up. You need to have it integrated with your firewall. It still needs to be able to talk to the entire internet and establish its TLS connections. And it's still, it's not web TLS, right? It's not like Chrome style TLS. It's still a separate software using the stack. So I doubt that would simplify anything.
Matthew, just going back to the scheduling, just a quick question. It would be great if we could get this in 3.3, but I don't want us to rush something and then regret it. So just hopefully a stupid question. If we put it in so that the client starts including an SNI header, do clients who don't understand that just silently ignore it, or does the recipient then break it if they haven't been upgraded?
So we tested that, and they silently ignore it in the current implementation. And in future, if those places where you have only a single choice anyway, you just happily respond to default choice if they provide it.
Yeah.
Okay, I mean, let's just run through some of these questions that have come up on the chat, if I may. I'll just pass them over to Matthew, if you can just pick them up. The first one was, what's the resource requirement per bridge? So this, if we've got that from the top.
The current resource requirement we have is fairly low, but the bridges are still ultimately demanding a long-lived process, a long-lived container minimum to be running, because they have to be permanently resident. And you're typically actually running two because you want HA. So we have, when you start to cross it out, because it is a permanently resident thing,
Well,
some cost.
that's true, but
Reducing it with this from per node having bridges to having a shared resource there that would be sharing for many nodes. So it is a considerable cost reduction just on a simple kind of cloud plan where you toss out a number of minimum cost VMs or whatever you need.
Yeah. Let's try and so in with where we're heading with all this design work is that the node becomes like a logical thing that's spread over multiple machines and different kinds of services, right? So rather than saying there are like multiple nodes behind the bridge, I mean that's kind of true today, but where we're going is it's kind of really one node that has multiple identities. Yeah. So
so that's definitely the next DRB to discuss where we've got to on that. We think we can make it that, yes, we're kind of going to virtualize the node identity so that we can have a kind of framework that can load a number of identities, a small number of identities at a time and run flows, and maybe can scale up the number of those dynamically. So those are the directions we're going with hosting more identities on less resources, particularly for those use cases where you have a large number of identities, but the actual workload per day per node is actually quite low. So on average, you might be doing quite a lot of flows, but you're actually, the transaction count per actual individual identity is quite low overall. So
if we've got time, we could, after the questions, maybe we can even go into that a little bit.
Yeah. So what other questions have we got here?
You can read them out.
So overall plan to use SNI seems reasonable. However, what is planned to risk assess secret storage and use it tenants don't inadvertently malicious access to wrong identity or certs? So we do have plans to work towards HSM storage of the things. I must admit there is an assumption here that the bridge and float, or the bridge has access to the key resources as it does now. So and I think we would only be able to do such checks in software, but it is done inside the trusted zone, not in the DMZ, this assignment. So SNI seems to be so in terms of is node info a long-term change, I'm sure we will change node info for other reasons. We might be scheduled as part of other more pressing needs on node info in the future. JC, please consider the environment and domain name, prod, UST, POC. I think that would actually be problematic for a lot of testing configurations, and people wanting to use open source nodes to evaluate might find themselves having difficulties with interop. So I'd rather that the SNI name is pretty uniform. Obviously, the certificates are isolated anyway because the roots of your prod or UAT are distinct certificate roots, and they won't validate. The TLS actually will just fail. So,
I mean, would it make sense to like have a hash of a short hash of the signing key of the zone or something like that? I mean, do we want to? It's a good point actually that JC's raising here. Do we want to support different? I was about to say the word node. I'm just violating my own rule. Different apps running in different zones behind the same IP port combination, or do we say no? If you want to have a testnet node and a mainnet node, you give them 2 IP addresses. That doesn't. I suppose it's not unreasonable, is it, to have 2 IP addresses?
2 IP addresses.
Yeah. I think it could be. Yeah. I mean, could hash the hash slightly differently, but I think ultimately the canonical representation, the X500 name hash, and then presented in some sort of character format is clear and unambiguous. And remember, the thing is, if you get a mistake very early in this handshake, there is no connectivity. It's very hard to diagnose because it's such an early flip termination that it's actually quite difficult to get the feedback.
You could potentially canonicalize, can't even say the word, the path of the certificate as well, so not just the identity, but where it's come from as well, like the doorman and root, and that would distinguish it further.
Yeah, maybe. I agree. We could maybe do a little bit. We could do a little bit of investigation. What makes sense there?
Yeah.
Okay, we've run out of questions on the chat at the moment. Are there any other questions from those on the call?
We just got 2 more.
Okay. Yes, so we have.
Yes.
Would it be possible to have multiple identity shows, say, able to perform security signing and this identity available in the node info?
Sorry. So I'll just read that. Would it be possible to have multiple identities sharing the same IP port and these identities able to perform securely signing and this identity available in the node info?
Well, that is essentially the proposal here, is that the signing identities are running the node and the bridge is dealing with the TLS secure comms layer. We're already kind of that separation already.
That's basically the goal of the whole effort.
Yeah.
Of what we've been calling
Having
Maximus.
considered handling the multi-tenant node as a subnet, well, that's the kind of larger scale protocol change that I did include a number 3 option, but I think it is quite radical, and I think it'd be very hard to see how we make that compatible. As I say, it's a thing that maybe we do need to start at least laying the groundwork for such things in the future, but I think it's way off that sort of thing. Maybe that becomes necessary if there's, future network mergers or something in the future that might be required just because of the way they're physically structured. But I think for now, we're assuming that all nodes can contact all nodes at least, through a bridge, through a firewall process.
So a question from me, Matthew, just going back to the one earlier about Corda 3.3. What I've heard on this call is discussion about what the domain, the domain that everything hangs off should be, and a question about whether we need to encode some zone identity to avoid confusion between dev and UAT. Do those change anything about your confidence about being able to get the client side support for this into 3.3, or is that just too high risk?
I think it would complicate that, because if there are changes in the way we structure the dormant configuration that have gone on, and there probably are actually, I don't know the details there. There's a possibility that just a minor change in the URL makes it non-contactable or something. So I think I'd like to keep the SNI header simple, the calculation of it simple, because there might be combinations I haven't considered potentially. I mean, we're treating it as really this is only the first step of a lot of back-end work that has to happen to ensure the message routing, and the authentication is really to do with the certificates that are presented. It's not.
Okay, so the implication of that is you can't host identities associated with different zones behind the same port. Effectively, they've all got to be the same.
That's
fine. Yeah, and that's fine. Okay, so it then comes down. So that I'm fine with that. So it just comes down to choosing a domain that isn't going to screw up. But if that's done, is this something you think you can get in for 3.3 because the code's ready, or that means we have to either?
Well, I think to just publish the header is actually quite easy. So yes, that could go in. We've looked at that quite closely, and it wasn't.
Yeah. So publishing is easy. The problem is deciding on how to hash it, how to encode it.
Yeah.
That's the difficult part. And we may be able to have like a plugin algorithm that we might be able to change in the future.
I don't know. We're just doing character transforms here. I don't think we want to be like the first 20 digits of SHA-256 or something is probably good enough.
Yeah. Yeah, we just have to make sure it's documented and agreed.
Yeah, we'll have to specify it as part of the protocol one day. So we should be able to. It shouldn't just call into a utility function we don't know what it does or might change its behavior. We should do it explicitly so we can document it.
Yeah. Okay.
Okay. I was just going to see if we could just hand over to Mike just for the last 5 minutes of the call, just a sort of quick discussion on the sort of the broader future direction that he mentioned earlier on, just to sort of give some background for everybody.
Yeah, right. So this is at CordaCon Japan. We talked a little bit about a project that we've been calling Maximus because it's big nodes with lots of identities to address the need that we kind of didn't fully anticipate in the first cut of the design of companies that want to host lots of identities on behalf of other companies. This work that you've seen today is a part of it. We've also been doing some work around proof of concept. We've done some prototyping of multiple flow workers, which has Matthew referenced already. This is where the node is starting to break apart, and this is in the enterprise version. I should clarify. The enterprise node is starting to break apart into what is effectively a cloud of microservices connected by the MQ broker. So we've also been doing work on splitting Artemis, which is currently an embedded component, splitting Artemis out, Apache Artemis, to separate servers and allowing that to be clustered and so on. So the long-term architectural direction is that a very large Corda enterprise node would consist of the firewall and the bridge sitting in your DMZ and integrated with your firewall for handling peer-to-peer traffic and encryption and decryption. That passes data off to a regular either Apache Artemis, or you can use the Red Hat's commercially supported version. They provide a version of Artemis that they do commercial support for. And then the node is, what's left of the node is connected to the MQ broker, and then most of the work is actually being done by a series of what we call flow workers, which are dedicated processes, maybe on dedicated machines, which actually receive and work with the message traffic. So the idea here is that because that's where the bulk of the work is going on, and the signing and the building of transactions and so on, you can scale the node horizontally by adding more flow workers. Moreover, if you're using a cloud infrastructure like Kubernetes or the equivalents in other clouds, you can scale with load automatically. So if your setup is getting overloaded, or you want to shrink at night, you can do those sorts of things because they're scale free. We've been looking at how we shard work with Zookeeper and all kinds of other interesting things. It's a very detailed and delicate job because you obviously got to ensure that no two flow workers are trying to do the same thing simultaneously. But it's looking quite positive. And in the very, very long run, we might allow Artemis to be swapped out for other MQ brokers as well. So if you already have an enterprise MQ service inside your company, and banks often do, financial institutions often do, you can use that. There's another aspect to this, which I touched on in my talk at CordaCon this year, in just last week, which is that we've been doing a lot of thinking about how to allow large, sophisticated organizations to scale their node, not just in terms of throughput and transactions per second, but operationally in terms of number of applications. So that this flow workers design allows you to do is have flow workers running in different parts of your network on different machines that may have different login rights. They may be firewalled differently. For example, if a department wants to quickly iterate on a Corda app that they're developing in collaboration with other companies, but then you also have a very, very important stable Corda app that your business depends on, and you don't want the two to interfere, you could potentially run them on separate machines, one in a labs environment and one in a production, very controlled environment. As long as they can both connect to the MQ broker and the underlying databases, as long as the flow worker can connect to the rest of the node, then you have potentially a very flexible setup. This is one of the ways we hope to fight the ossification that can easily happen when IT departments want to defend a valuable piece of infrastructure from chaotic, anarchic, buggy innovation. So there's a lot to this. Matthew is the lead on this effort, and he's working on it with the HA team, who is also in the room. So you can see we're putting a pretty significant effort behind this kind of initiative.
So I have one more question. And is the decision? I mean, I think there's consensus anyway around the initial implementation of this. But does any future of Maximus work affect this decision? Do we need to consider future Maximus work when we're thinking about this?
It's really a precursor for any kind of sharing of identity in any way. And we do need something that can support this sort of sharing.
And the choice between SNI and modifying node info makes no difference to future.
Yeah, it doesn't really.
Okay. So I think it sounds like SNI gets it off the blocks quickly. May well prove to be a viable solution long term, but if not, then there are further options that you can migrate to.
We did evaluate as broadly as we could.
And just because I got a question on the back channel from James, just for everyone else's benefit, the reason why I was pushing on 3.3, not if it turns out to be too risky, but having clients set this header Having enough of them in the population, either on Corda network or elsewhere, will be a prereq to being able to roll out this feature. And it'd be quite annoying if people wanted to launch with this feature, with enterprise, but they can't because there's too many nodes without the capability. So the sooner clients are assessing it, the better.
Yeah, sure.
Yeah, I think that would be best.
There's a question here from JC. Please keep load balancing on your radar. I didn't mention load balancing just now, but the idea here is that we already support multiple IP addresses per identity, in effect. In the unlikely event that your firewall float was getting overloaded with traffic, I really hope that happens, because that would imply we're very, very successful. You could just bring up another one. MQ brokers like Artemis support clustering, so adding more. Effectively adding more nodes to the MQ cluster to handle more traffic. And then the MQ system also understands how to do things like load balancing traffic across multiple workers. So the bottleneck would actually end up being the database, we think, in that case. And, the performance team will eventually, that will be the top bottleneck, and they're looking at things like offloading some of the traffic to scalable key value stores.
So in terms of load balancing, it's quite tricky in terms of some of the ordering requirements that we have. Yes, with regard to load balancing, we're mostly looking at load balancing more from the perspective of the kind of flow worker side for the future. I think we're quite confident we can do sort of dynamically hosted identities, so kind of virtualize the node. I think sharding of individual flows is definitely on our radar. It's definitely a thing we want. We've been POCing it out, but it's quite challenging, and I think we'll have to regard that as a thing we'll deliver a bit further off. But if we can deliver, you can run, say, 100, maybe several hundred nodes with a relatively limited amount of infrastructure that's for these cases where we've got low utilization of any individual identity, then I think that would actually meet a lot of our current use cases. If you've actually got thousands of transactions per second, I think we would strongly recommend it.
Yeah, maybe I can give you a little bit of context. JC, just to give you where I'm coming from, the idea for us is to be able to run thousands of identities. So what I would like to do is declare these identities somewhere and spin as many workers as necessary. That I need to ramp up my workers. I do not want to redefine my identities just because they have more, a higher workload. So what I'm looking for here is some kind of a decorrelation between declaring the identities and the node setup, so that we can just throw more workers at the infrastructure and to increase the firepower.
Yeah, that's how the design. Yeah, that's how the design works. Yeah. An identity is ultimately just a private key, public key pair. So the idea is every flow worker would have access to the key pairs for every identity. And then, if you have one identity that's doing 100 times more than other stuff, then maybe like 90% of your flow workers are just working with that identity's key. And then, but they can balance smoothly. That's the idea. So Kevin has asked, how does this relate to LDAP integration that was promised for Corda Enterprise? I think it's not related.
It's not really related, although, so this is all very much on the peer-to-peer front, this particular DRB. With regard to some of the Maximus work we've been looking at, we do intend an RPC component that is essentially you specify the particular node identity you're talking to query the vault or to start flows. So we are looking at extensions of the API for that, and obviously to share that resource. In terms of dealing with LDAP, that's actually more part of the specific service to do with permission checking, and that's not really in the scope of this team's work. That's more some of the other teams.
Yeah. So the you're supporting. So the idea, what we've been imagining LDAP integration to mean so far, and it may be that there are other ways to use it, is you have an LDAP server somewhere in your network, and you can point the node at it, and then you've got single sign-on between all your other services and also Corda RPC. Now, where we might there's going to be this interesting question of how do we integrate RPC with a sort of multi-identity world. One obvious way is to say each RPC user you define as like a login for one identity and acts as that identity. But then if you had 100 employees who could log in and like 100 identities, you'd have this combinatorial explosion of users. So we might not go that way. Another possibility is that you might want to explore the network map and all of the identities. What we've built is basically a directory in the form of the network map, and exporting that via LDAP, so you can use LDAP explorers and things. That might be an interesting project. I don't know if we'll do it. I don't know if there's any demand, but that's certainly possible. And then there's another final component of Maximus, which we haven't talked about yet and probably won't until sometime next year, which is, you're going to get companies who don't want to delegate signing authority to a third party, right? I mean, we're kind of it's a little bit risky what we're doing here, because we're kind of stretching the metaphor of a digital signature. If another company can sign on your behalf and pose as you, is that still a legally binding signature? Does it need to be a legally binding signature, for one? I mean, are we actually going to go to court and say, well, you signed it, so it's valid? Our vision is yes, but this notion of like of companies hosting thousands of identities on the behalf of their customers breaks that pretty badly. So we're looking at ways we can handle that, either through marking them as like, this is not really that company, it's almost like a power of attorney type relationship. Another way is to implement client-side signing, such that the companies have the private keys generated locally on a smartphone app or a little device, sort of what the Bitcoin community have pioneered, and then everything else is done in the cloud by the hosted provider. And when your node is acting as an identity and one of your flow workers needs to sign something, it suspends and routes the request through to the user, who then pushes a button on their little device or however it's done. The signature gets sent back to the node, perhaps via RPC. The flow unsuspends and continues. So we're looking at ways to have these big centralized nodes with lots of identities, but then also decentralize them a bit as well.
Okay, guys, at that point, I think it's over. I'll bring the call to a close. Thank you very much.
Thank you for the questions.